As we cross the finish line for 2022 and head into the new year, there are two teasers I'd like to show you for 2023. One is for the next video in the Celestial Sphere series, and it's about the inner workings of the cryogenic cooler on the James Webb Space Telescope. As you can see, our protective atmosphere is not very cooperative when it comes to us viewing the universe. We have, however, overcome most of these shortcomings of our atmosphere. We've resolved most of these issues relating to clouds, precipitation, and haze by locating some of our biggest telescopes in some of the highest and driest locations on Earth that's practical. The Unit Telescope at the Very Large Telescope Observatory is one of the largest optical telescopes. It's located at an altitude of 2,635 meters in an area that receives less than 10 millimeters of rain each year. The sky is also clear 75% of the nighttime. During these clear nights, we still have to deal with the other issue, that is, the atmospheric distortion caused by heat-induced changes in the index of refraction of the air. For this, we employ adaptive optics. In a telescope with adaptive optics, one of the mirrors is deformable. This means that the physical shape of this mirror can be changed by applying an electrical signal. By changing the shape of the mirror, for example from flat to bumpy in some areas, we can counteract the thermal distortion caused by the atmosphere. But how do we know by how much we need to deform our deformable mirror? Typically, a powerful laser is shot from the observatory into the sky to a location of interest. The detector is then focused at the end of the beam. Since the system knows what an in-focus point of light should look like, it will compare the actual image that it's looking at with that of the ideal point. From this information, it will then send the appropriate signal to the deformable mirror so that the deformation created in the mirror will cancel out the distortion in the image. In order to deform the mirror, many small actuators are used to slightly lift parts of the mirror. But even with a technology as advanced as adaptive optics, we are still unable to overcome one of the biggest shortcomings of our atmosphere. That is, the atmosphere severely diminishes the energy of many of the frequencies that we're interested in. You cannot fix what you've never detected. So to overcome this problem, our only choice is to place our telescope above the atmosphere and in space. There are many challenges to overcome in order to successfully place a telescope in space. The level of difficulty is increased significantly when we're deploying a large-scale infrared telescope, the kind that Webb is. But it's still worth it because of the possibility that this telescope can now open up. The next teaser is the first on reflective layer, and something I've been working on for about a year now. It's a science fiction story, but in a documentary style similar to the videos in the Celestial Sphere series. There's an underlying story that will unfold in each episode. There are no heroes or villains, just the story, the science, and a little bit of fiction. Happy holidays. Here's the second teaser. I'm Dex DFX for Reflective Layer. In the past, colonizing another planet or moon was seen as something inevitable. Most had their eyes on Mars because it posed the least challenge for humans to establish a self-sustaining colony. Still, a challenge nonetheless. But what would have surprised people from the past is that 150 years after we safely landed the first operational probe, Viking 1 on Mars, we would have colonies on all rocky planets and a handful of moons. Earth acted as one voice for a change, one strong voice when it came to exploring the solar system. But the most important aspect about this expansion into space is that we were motivated, highly motivated. Motivated to the point where we were willing to spread our resources really thin to achieve our fast expansion into space. But without this expansion, we wouldn't be here today on Enceladus. We're here at CARL, Cousteau Aquatic Research Labs. It's located on the plateau 5 kilometers under the Herschel ice sheet, which itself is 3 kilometers thick at this location. There's a colony of about 1,000 people on the surface of the ice, but that's not our home of operation. We're a team of just 5 that are searching for life in the ocean, but so far, we have nothing. We have some leads, but nothing substantial at this point. Most of the time, we just watch over our robotic craft as they explore the ocean, collect and analyze organic materials. If they find a new organic material, the computer will alert us and we will do additional analysis on that compound. We've been doing this for 2 years now, so we already found most of the easy stuff. We now get a hit about once every 3 months, so that's plenty of time to sit around and do nothing. Bored out of my mind, I started thinking, why are we here in the first place? Not just under the ice or even Enceladus, but the reason humanity had to expand so quickly into the solar system. I started thinking about the events that motivated us to colonize not 1 or even 2 worlds, but 8. To understand what motivated us, we have to go back about 100 years to a particular date, and so it begins.
Skycam maneuver has started. About 20 meters off the surface.
The date is 18 February 2021. Space enthusiasts should know this date. The Mars 2020 mission just delivered Perseverance on the surface of Mars.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
But while everyone was celebrating the success, something went missing. Something big went missing. Something like an entire comet. This is comet P2019 LD2. When the comet was first discovered in 2019, it was thought to be a Jupiter Trojan asteroid with a comet-like tail. A Trojan asteroid is an asteroid that shares the same orbit as its host planet. In this case, it's Jupiter. They're located at the L4 and L5 Lagrange points. But after observing for a longer period, it became clear that its orbit was too unstable for it to be a Jupiter Trojan asteroid. And with its comet-like tail, it was reclassified as a comet that was orbiting the Sun. But even with longer observation, its orbit was still deemed somewhat unstable, meaning it would drift significantly for every revolution around the Sun. The size was estimated at 14 kilometers in diameter. Considering the distance from Earth and the size of the comet, radar is not an effective method to determine the size, so instead, the absolute magnitude or brightness of the comet can be and was used to get a rough size. This is important because when the comet did disappear on 18 February 2021, the few astronomers that were tracking it didn't think it was a big deal. After all, its size is based on its brightness, which is ultimately based on the reflectivity of its surface and the angle at which the surface is observed. The comet could have been hit by another object and is now slowly spinning, which is causing its brightness to vary. But all that speculation changed 8 months later when a new comet was discovered approaching Mars. Its size, based on its brightness, was also estimated at 14 kilometers. Initially, this was not too concerning to NASA, ESA, and Israel, which all had orbiters around Mars at that time. They were already familiar with this kind of close encounter. In 2014, comet C2013A1 commonly known as Siding Spring, flew past Mars at a close distance of 140,000 kilometers. During that encounter, NASA moved its orbiters to the other side of Mars to minimize the possibility of being hit by dust from the comet's tail. So when this new comet was detected, similar actions were taken. And because of that, the Mars Reconnaissance Orbiter, or MRO, did not capture images for 3 to 4 hours of this comet, which by that time was believed to be the missing comet P2019 LD2. When it did capture an image, the comet was more than 50% dimmer, making its diameter, based on its brightness, shrink from 14 kilometers to 9 kilometers in just a few hours. This sudden dimming was puzzling to astronomers as they tried to find an explanation. Then, things took an interesting turn.